I've mentioned the inputs in UI, so let's finally take a look at an example of the local UI in input logic. Let's create a new script right here. Let's call it new player component. In this component, I'm going to show you what happens when you press the key down. So I'll make a new function saying key down, and whenever I press A key in my press down A key in my keyboard, I'll make something happen. So in this entity event handler, search for the key down event. In this code right here is there as a default. So you just have to code the logic here. So I want to say if key equals to keyboard key, and I'm going to choose A, then whenever I press the A key, this function here will run. So type the magic keyword itself, then the key down function with the parentheses. Okay, so right here means that you can do something if you press the key down. That's the input logic. And so before clicking play, we need an entity to attach this component. So this new, oh, it's too small. This one will be our new component. We have to add component that I've just made, new player component right here. Check that it's added, and now you can play. So every time I press the A key here, every time I press this, you'll get the script printing out. And you can see that the script is running from the client. And actually, if I were to run the logic here, if this is the server and this is the client, it's another client. Let's say we have a client here we have client A here. And there's B in each of the client and the server. And if I were to run the logic here, only my client will be changing the logic. We have a client here with A in, another client that has a character B. If we're in the same space, my client should be able to see B, like this. And there's B in my screen, and also client B will be able to see A. And if you look at the server side, the server should also see both A and B. Now let's say I change something for A. As this is an input, that's a client's logic. I change something here. I'll give this client a property called power. And let's say I want to increase this power. Every time I want to increase, I'll press A. But then, when I do that, there will be an issue. The character here should contain this new player component in order to increase the power every time I press the key down. So the input happens in the client. In taking this approach, you'll end up with the power increasing only for this one. And the rest won't see the change. So at this point, you need to sync the property. Otherwise, you're going to power up your character here, but the other users will still think it's at A. So you need to take the execution space control properly and make adjustments to make sure everyone's on the same page. So it's very simple. So I'll just set the execution space for this as a server. Then say power here, and I'm going to use this property and make it increase every time I press the A key. So what does this mean? Here before there was a client, two clients, and even though there was a change in this logic here, this was the only client that can see the changes. But now, every time I update the property here, I'm going to send this to the server. And then the server here will say, okay, sync. Okay, sync. And then send it back to each of the clients here. Get it? So now the change will not happen in your client, but it will happen in the server. So to be precise, first you call this key down function for A in your server. Then the server will run it, updating the power property. And then the moment you call the key down here, the key down function, it passes over to the server space. Here, it passes over. And then when the power changes to 1, you can let the client input change the synchronized values. And if sync is on for the server's property, the server will sync your character's power value as 1. Power. S1 and S1. So by doing this, you can let the client inputs change the synchronized values. And remember what happens when you sync. The onSync property function right here can be used. Let's say log name value and see when I press A here, when I press A, oops, I forgot the 2 dots right here. Now let's clear up and play it again. Okay, whenever I press A, yeah, you can see that the power value is going up. So this is how it works. You can control things moving between the server and the clients freely by using this concept of networks. Let's wrap up. In this session, we learned about networking in MSW. The key concepts we covered were synchronization for properties and execution space control for functions. And values are updated throughout the network through synchronization, and execution space controls decide where the function can run, client, server, and etc. We also covered the basics on how to write the logic for the server and how it automatically gets processed in the clients. And also synchronization and execution space control are used for the properties or functions of this native components. And as you can see, just choose something. All of these are set to sync. Well, some aren't set to sync, but most of them are. Here's an example which is not set to sync. But you know that every client has a different view of looking at the game. So normally, the client controls the camera it's using. But these are set on the client where the server is allowed to change as well because it's not client only. but it's a client. So if you change the value of set zoom on the server, it syncs with all the clients. And the same goes to shake camera. If you want all clients shaking at the same time, you can call shake camera from the server. So we implemented the native components through execution space control and synchronization. You can do the same on your scripts. So make use of the sync and execution space control options, and you'll be able to create your own script, component, and logic. These are very flexible and powerful tools once you get used to using them. So try practicing and get familiarized as quickly as you can. That's it for today. Thank you for watching.